Hello, everybody. My name is Tomasz, czyk. I come from Poland. I'm working at the Wild School in Tychy, democratic school, but also belong to the Polish Astrobiological Society. And today I would like to talk a little bit about greenhouse on Mars. Green house on Mars because I see many combined activities between greenhouse and eduhouse, so education. So I decided to title my presentation like you see at the moment. Of course, today from the southern hemisphere, you can see Mars in the conjunction of Saturn. I like very much these planets, Saturn and also Jupiter. And this is a small look at the sky to see where the Mars it is right now, looking from the Earth. And a little bit in detail, when you can see Mars with these two moons, Phobos and Deimos, and what I would like to present you also, this is the look at the Mars from Deimos. Probably such view from this moon, one of these two moons of Mars, you can see looking or being there. I would like to try maybe somewhere. Yes, after Suriendo Saha presentation during our mission, during 109 mission, I focused very much on this slide, where we can inform about genome instabilities and mutations. That was a kind of tip for me what to do or how to describe what we can do measuring genome, measuring chromosomes, measuring our DNA. And of course, we are flying blind a little bit when we consider techniques, medical techniques, or possibilities to research or to conduct research using plant or human genome on the exposition of cosmic irradiation. And in plants, we can see, for instance, instabilities in chromosome structure. So you can see translocation, you can see inversions, deletion, or forming circle chromosomes. And the other modification, easy to study. Before I would like to say a few words about greenhouse on Mars. I would like to share the view of internal design of such habitat, which is on Mars. It could look like we see on the slide, is beautiful, and probably some cases, some rooms are designated to conduct research. I would like to see something like this. Maybe it will not happen on Mars directly, but maybe in the future, in the laboratory, we can build or just present or just prepare for educational story. But taking into consideration that we have some point of view on a habitat Marte, so now we will talk about greenhouse, which is directly in this point making by the circle, green circle. So we can say that the greenhouse is just in the middle of the habitat Marte, or proposing how the habitat Marte looks like in the future. During 47 Habitat Marte analog mission, virtual mission, Yash Ratot proposed how the panel, the part of the greenhouse can look like. This is 8 meters of diameter and possesses 3 floors. This facility contains, of course, dormitory, small kitchen. It is also room, toilet, small vertical garden. So we know that probably vertical gardens, they will be there, or the room for 3D printing. I'm a little bit confused because dormitory with beds, probably beds will not use during our mission on Mars when we would like to be on this planet, probably low gravity, microgravity, we can say, is not good. It's not good for our position, vertical position, horizontal position. Sorry. So probably beds will be used, but of course we will consider this part of furniture to rest. And below on the slide, I would like to show you how my students also try to try to use 3D models of Mars habitat using such techniques like Tinkercad tools. Of course, this is the very beginning step, actually an initial project. So it isn't look like a typical 3D model of the habitat, but of course, maybe in the future, it will be. From my point of view, I think that internal design, which can be very combined with the previous proposal, how it should look like, maybe also like this, we can consider the greenhouse or the part of the greenhouse looking at the snapshot. This is German experience, so we will see that there are some parts in the greenhouse where is the main entrance, of course, door to service section. So here we can prepare everything what is needed for plant growing, for plant breeding. And actually there is a big container for plants. Because our proposition is to make a greenhouse like a circle, so of course we can just produce containers in a circle-like shape. This is only a simple view what can be visible in this model of the greenhouse. To be more specific, it looks like that. So there are some parts, small rooms for power distribution, the humidification system. So of course, some vessels for oxygen and for other supplies which are needed for plant grown, for plant breeding. Many things in detail, which are creating this part of a very important place in the habitat. Still, if we consider habitat Marte or the other habitats which can be placed on the planet Mars, so I think that the distribution and packing everything which is needed, which is required for greenhouse maintenance should be very carefully thought over. But I am still captivated with this proposition of some parts of breeding, plant breeding, as you can see on the slide. So Planter from the Expanse movie. For me, the Expanse movie is one of the important movies actually about science fiction, because here many important facts about physics meets reality. And I look I like very much, like these planters can be visible. And also NASA proposed revolutionary green wheel hydroponic garden. As you can see, it is very compacted. We can have such things at homes, for instance, trying to do with the plants or herbs or medicinal plants as we want to do. But of course, talking about greenhouses, we also should mention about technologies and machines which are necessary for the operation or installation. This is an example of a warehouse and many robots which can pack every place here for packing. Of course, there is a directly link to show how it demonstrates in the reality. So I think that making something possible in our greenhouse, which makes our greenhouse highly automated in the future, maybe not during the first mission, during the second or third mission, but maybe after a few missions, we can prepare our greenhouse to be highly automated, and maybe such pattern of automation maybe can be considered. Technology, we can say. So for me, the most important will be irrigation and temperature systems, monitoring systems for air quantity and quality. So which levels of oxygen and carbon dioxide we have. We should monitor that. Monitoring system for water quality and consumption. Of course, to make the greenhouses highly automated or just automated, we need some robots. And these robots can be responsible for plant care and maybe in the future for harvesting. Automatic system for monitoring level of ripeness. I mean, maybe using such robots or the other automatic systems, so we can, for instance, take into consideration the colors of ripeness during the ripeness. So CCD cameras, they can do, for instance, they can see what is the color taking into consideration ripeness. I would like also to produce or be responsible for vertical gardens and of course, photosynthesis, different quality of light can increase oxygen production, and oxygen at all should be recuperated and in some way recuperated, and of course be in the whole station available. Hydroponics and aquaponics may be common techniques, but of course there is a small difference between them. And hydroponics, aquaponics, it depends, of course, what can be done under the settler. We can testify new cultivars during our mission. And because educational purpose of being a proud member of the Habitat Marte analog mission is also to be like a tutor or mentor for EduVision. So the section when we can consider educational purposes, not only, for instance, for the people being also on Habitat Marte, but also for the young people outside, I mean on Earth, which they can track our activities down, and also they can work on something. We can, of course, prepare being at the Habitat Marte during our mission. So that will be in the EduVision workshops, new technologies also lab for 3D printing. I would like also to see in the greenhouse a small part to find it as a relaxation area. So for resting, for stargazing, maybe telescope will be, of course, taken with us. In some cases for reading or meditation. Yes, vertical gardens. So there is a specific look at how they look like. We have some plants that are spotted just below each other's. And of course, here in the wall, we can say that will be some fluids important for hydroponics, and also some machines which can recuperate, they can recuperate oxygen after photosynthesis. Just steps we need to present, we need to be done to maintain hydroponic of these flowering plants being on the analog mission, using everything which is needed for hydroponics. Hydroponics, when we just talk about this important plant growing techniques, so looking at the hydroponics market in the USA, we can see that every year is tending to increase as a technique used for plant growing. So every year we have some big step to use this hydroponics. Maybe in the US market it is like that in most cases this is aggregate systems. So many different things should be done to provide hydroponics. There are some vermiculite, other things, cultures to conduct hydroponics. But in Europe, this is just in the opposite side, because we use more liquid systems than the aggregate systems, like we can see that in the USA. But what is, of course, very important and worth mentioning, that every year we see this big tendency to increase hydroponics, to consider hydroponics as a main technique for plant production. And some small examples taken from the NASA gallery, that we can see different plants. Here we have some allium-like plants. Here probably there is a salad table prepared for hydroponics. Also here salads. So these plants, which can be considered as plants for food production, being on mission, being at the habitat. An example as a scheme of aquaponics, where it should be combined with fishes, because some products, of course, and everything what we can just meet in the water can influence on a quality of plants growing in aquaponics. But what will be grown? There is, of course, big question, considering technologies and machines in the future, in the future missions. Now, I think that the most important are lettuce, broccoli, spinach, or tomatoes. Maybe there are some other vegetables or foods which should be also considered as a future food during the mission. But I would like also try to use weeds. Maybe at this moment, this is a kind for laughing, but why? Weeds, medicinal plants or herbs, and also truly to propose rapid cycling brassicas. If we take into consideration weeds, I mean Egopodium podagraria, for instance, so goutweed, or we can also call it as a bishop's weed. So yeah, they are commonly called ground elder, sorry. So this is a species of flowering plant in the carrot family. So this is Apiaceae, and this is an enemy of evenly trimmed lawns. But it also has a very specific influence on our organism. Young leaves, not flowers, not blooms, but young leaves, maybe we can use for detoxifying and regenerating effect, or for detoxifying and regenerating on our organism. There are also other purposes like anti-inflammatory effects on the organism. Young leaves also supporting digestion and metabolism. So metabolism of future astronauts. So this is not the main food to eat, but we can add, for instance, during hydroponics production of weeds, yeah, to achieve these goals we have here on the slides. Also, we can use for calming astronauts down and to accelerate the healing of minor wounds. So this is probably not maybe on the first mission, but we can consider weeds as additional plants for food. But I mentioned before about brassicas, strictly speaking about rapid cycling brassicas. And here you can see U triangle. This is U, Japanese scientist, and he proposed this U triangle of relationships in the Brassica genus. So here you can see that just in the corner, you have diploid plants. So Brassica nigra, for instance, black mustard. And here we have a Brassica, Brassica jansia, Brassica campestris. So these, like Brassica nigra and Brassica campestris, these are parents, so ancestors of Brassica jansia. Here we have in the opposite corner, Brassica oleracea. So many common cultivars in this species, like cabbage, broccoli, like cauliflower, kale, or Brussels sprouts. And Brussels, we can also consider as a future plants for food production during the missions. So Brassica oleracea is a diploid plant, Brassica nigra is a diploid plant, and both, they are ancestors of Brassica carinata, Abyssinian cabbage. Here, Brassica jansia between these two diploid plants, and jansia, this is brown mustard, so Indian mustards, and also Brassica campestris, so we can consider as a turnip, Chinese cabbage, field mustard also, but yeah, these are some cultivars belonging to this Brassica campestris, one of the parent, and Brassica oleracea. That's yeah, we can see that between them is Brassica napas, so oilseed rape, canola, as a offspring between Brassica oleracea and campestris. So a hybrid species resulting from interspecific breeding between these two diploids. And due to hybridizations events, oilseed rape is allotetraploid, so we can say that containing 4 genomes of these two diploid species. And Brassica, rapid cycling brassicas can be considered because they have a very short vegetative period, in comparison to the cultivated ones. Here you have some comparison, life cycle comparison in days between these two diploids, and of course, not considered for any mission Brassica napas. Here we have cultivated plants and rapid cycling. So you can see that in days, we can see, for instance, seed maturation after 60 days in comparison to the cultivated one, Brassica oleracea, that we on average have 33 days. The second diploid, Brassica rapax, or germination, after 7 first leaves, we can observe on average after 11 days. Flowering and seed maturations, you can see just in this position of the table. And also the allotetraploid, so the offspring between Brassica oleracea eurapa, also has been measured for these 4 important points of any life cycle in plants. And because I am a cytogenetist, so also I looked at the chromosomes, counting for any chromosome instabilities, maybe in the context of what Suryendu Saha also told us about the genome modification, about the genome instabilities. So these instabilities we can observe. And we see some differences. Because the greenhouse is, in my cases, strongly combined with a kind of educational purposes. That's why I call greenhouse as a green edu house. So we have also a kind of edu division. And we can prepare edu division as a section during the mission, during the analog mission, during the true mission being on Mars, but also it can be a kind of spin-off, a kind of series of technologies we can just have on Earth, repeating, using some protocols, routines, or guidelines just checked during the missions. And for instance, in the south of Poland, we have a kind of, you can see here on the slide, so there is some greenhouses looking like that in a circle-like shape. And for instance, they are responsible for producing herbs, plants, not only for food, but also to conduct any researches. That's why I would like to say that we can have a very close combination between those what we can describe during the mission and what we can use after on Earth, for instance, in the case of any educational purposes. And just an example what young people can do during such edu division. Yeah, they can measure, for instance, growing of plants. So this is just for astrobiological, we can say, experiments that they can measure, they can try to grow plants with a kind of culture without any important elements, without sulfate, without potassium or calcium or magnesium. So they can observe, for instance, what it is happening with the plants. And just to take some conclusion at the end. Or we can prepare some tubes with different culture solutions and also try or ask them for plant growing. This is a kind of small, being on Earth, greenhouses, also in the context of astrobiological area and exercises. And of course, after that, it can be a simple table for observation skills, because the most important thing of every experiment is just an observation. So that should be taken into consideration. But which possible resources we have to generate in situ? I think what should be important from Earth, there are some samplings, seedlings, and of course, seeds. Maybe, seedlings or small plants, which should be taken with us, flying to the Mars. So when we have to take it from Earth, and of course, try to conduct any other growing experiments in the new place. So during our mission in the greenhouse, in this case on Mars, amounts of water must be calculated and imported from Earth. Also, anything what will be eating. So initial food, some instance. This is also supplies which should be considered to be important from Earth. Breeding of edible insects, we can say entomophage. So search for new sources of animal proteins. This is just what can be parallel to the meat, so artificial meat, or as the new definition, novel food to be required as equipment, and also must be important from Earth. What I mean about entomophagy, so for instance, that can be larvae, grubs from the Coleoptera or the Orthoptera, like silky worms, also Hymenoptera, Lepidoptera. This is the order for butterflies, and of course, I mean about larvae. But in less situation, also larvae taken from the other orders, I mean Odonata or Blattode. Here there is a kind of article, unfortunately in Polish, but it can provide us which larvae maybe can be the best option for food. And of course, what should be taken from Earth during this mission? So this is a cocktails of algae strains, which are very important for oxygen production, and we cannot forget it. But what is very important and worth of mentioning, self-sustaining greenhouse and overproduction of food is not a case of the first Mars mission. And this goal will be achieved later, I think, in the future, after many, I cannot say how many missions we have to go through, but that will be not the case of the first mission. Organizational structure. So I think 4 people will be engaged during this mission. So we have a chief gardener, which can be on full time. Also, it will be scientist as a deputy CEO, also for full time. But also we need a kind of working part-time worker, so assistant, like a researcher, and also a technician. And if we take into consideration just profiles which should be filled up. So I mean that chief gardener should have some degree, academic degree, like doctor in astrobiology, biology, horticulture, and also after analog astronaut missions. So a kind of experience. Maybe it can be done or achieved after analog mission, but also making some creating some experiences during the other important missions, maybe on Earth. It will be responsible for continuity of breeding and food production, for planning of all hydroponical experiments. He will be responsible for calculation of required food. That will be achieved, that will be possible only in the cooperation with our physicians. And also chief gardener will be monitor plants and all systems, also in cooperation with technicians or engineers. Deputy CEO should also has degrees, academical degree, not only in biology, also can happen in the other natural sciences, other disciplines, and should be also after some analog astronauts missions. I called this deputy as a mirror worker during the absence of CEO, cause of illness, cause of catastrophe, cause of death. There is a mirror worker, so he knows, she knows all protocols, routines, and know where there are some guidelines for everything, what should be done, what should be achieved in the greenhouse. So knowing the procedures, continuity planning, monitoring. So also it can be a chief of educational division and also responsible for new hydroponic, aquaponic techniques. These assistant researchers, so master's degree, it will be a sufficient level of education in astrobiology, in biology, horticultures, but also in the other academic disciplines. So this is the person which can help to deputy CEO whenever necessary. Yeah, and some other responsibilities we can just see on the slide. So to monitor of plants, to make, to collect, to study samples, to conduct research on plant cultures and plant breeding during greenhouse activities. And what can be also, or should be also considered, some maybe own research program. It can be also a direction to make a PhD. So PhD students can also apply for this position as assistant researchers from different institutions. Of course, technician, where it will be he or she will be responsible for technologies in practice, to use any known technologies in practice. So technical duties, he, she can be responsible for collecting the data, and also in a cooperation with our engineering or informatics, people which they are after informatics to service highly automated greenhouse, or part at least. If we talk about training, astronaut training programs, so I think that a couple of these topics should be considered as research and breeding methods. So to know how to conduct research, of course they know, but I mean which protocols for conducting research, talking about specific things, should be done. For instance, horticulture, hydro and aquaponics, also climate science. So what we can learn, how we can improve as humans our climate. That will be also combined with a spin-off. So space psychology. So that will be an answer on a question, well-being. mindfulness, communication skills, integration, maybe not only from time to time, but maybe regular meditations, just to peace our body, for instance, after something important, but also to topics of training of our astronauts belong astrobiology. Training also can be based on a nutrition, so what we can eat actually, yes, that is the most important thing. Also first aid, to achieve to get skills from the 3D printing, for instance, or regularly to make appointments, how to solve problems, because they will be, of course, during the mission, and it can be achieved using or by the use of dragon dreaming, a special techniques from the space psychology. We can also call it brainstorming. Yes, this is a couple of links to the videos how to train astronauts, and I just divided them to a few sections, like conduct science, an introduction, still in microgravity, or cooking in space. Maybe that will be important for us. Probably it should be science in the microgravity. So this is the part for edu division. So deputy chief gardener, maybe he or she will be responsible for to conduct science, for popularizing that, and for instance to record videos during the missions, and that can be combined with these areas of education on Earth, and also how to fit astronauts during the space. Now, of course, we know that this list will never come to the end. Resources. I think for five astronauts, so full resources look like we can see here on the slide. So due to microgravity, each astronaut consumes on average 1,400 up to 1,800 kilocalories per day. We have a low gravity, so we do not need be more energetic because there is no force, no force, no such force, for instance, for moving. So actually, on average, a man should have 1,800 and women 1,400. So for 1 week, an intake should have 9.8 thousands up to 12.6 thousand kilocalories. And it means that food needed for a week should deliver to the astronauts just on average 45,000 up to 63,000 kilocalories. If we take into consideration water resources, so it is 3 liters per day per person, so it takes 124 liters. And according to the US Department of Agriculture, to be self-sustainable, approximately 40 square meters of plant culturing are needed for one person. It takes 200 square meters for 5 astronauts. So we know that this is a challenge because we have a small part of the greenhouse to be self-sustainable. If we take into consideration guidelines, so it should be considered harvesting schedule, guidelines for educational activities of the entire crew, for water consumption, bio waste we use, also what is very important for health, and crew well-being. Also guidelines for potential disease or even death of a crew member. So it is possible and should be considered as a scheduled danger rehearsals. And also, what is important for me, considering space psychology. So any guidelines for small events and crew integration, new communicative skills, even crews supervising. If we talk about routines, so protocols, I have mentioned that. Maybe I won't read all these protocols, but just talk or say about the most important ones. For plant breeding, growing, and care and irrigation. So this is the main duties all staff working in the greenhouse. Plant health, protocols for algae culturing, for harvesting, for plant experiments, and of course for insects culturing. Another section, of course, very important, I have mentioned about this, but also belonging to the duties of the greenhouse, duties of the workers working in the greenhouse, maybe not in the same area where the plants are, but maybe, why not? Any protocols for waste disposal, greenhouse maintenance, and of course for research and innovation, because workers working in the greenhouse, so in a half, at least all of them are scientists, so conducting new research and introduction and new innovations, yeah, they will be also responsible for. So cooperation with the other facilities that should be also any protocols, or we can say routines for reporting to the main CEO. Health and safety protocols, that should be on the first place, and it is. Protocols regarding hygiene during work in the greenhouse, what we can wear, what we have to do during something, what to do, protocols should be considered when we talk about plant diseases or with about emergencies. They can also happen during our work. And very important, safe handling of plants, seeds, how to maintain stocks, and of course, to maintain the life of algae. If we talk about protocols for any occupancy, this is my proposition. Crew is responsible for own food. No, this is not like this, that every member of the crew is coming to the greenhouse, because there are specific crew inside. But maybe it is he or she is engaged for this food production. Viewing area with the music or without music. Probably online cameras for educational purposes. Maybe also some part of Edu division after deputy CEO supervision. Meditations or mental care supervisions. We can also organize events, for instance, birthdays, just simple birthdays. And video meetings for educational purposes. So conducting, for instance, something for science communication in different disciplines, may be recorded and maybe transmitted later to the section, edu section on Earth. If we talk about protocols for food microproduction, I am more than sure that these are duties of the greenhouse. Protocols for 3D printing. So everything or every protocols and dedicated software for food storage and transport containers. We have to print it because small part we can take from the Earth, but being on Mars, being on a mission, so 3D printer will be, of course, a very important tool to use. Protocols and specific software for tools needed in the greenhouse, in the greenhouse laboratory. Any protocols and specific softwares to testify for 3D printing based on biomaterials. Maybe this will be not a case of the first mission, but we should consider biomaterials as materials to be printed. Protocols and run of specific softwares for 3D printing of any materials needed for electronics, technical or engineering. What is very important for me, so what we can use, we can reuse. So recycling, upcycling, because zero waste is just not a simple definition that I believe, but we can also use it. So improvement, waste management, how to solve the problem with waste and bio-waste. Plant cultivation experience, vertical gardening experience that can be also simply applied to earth. Growing plant species in extreme conditions, cosmic radiation, toxic Mars regolith. We can, of course, improve, and every mission will be responsible for improvement. Toxic regolith to be more available for plant cultivation and growing. So if we would know something new about this, that will be also very important for us. Improve techniques for rapid cycling brassicas growing, because I don't know, even if I worked with the rapid cycling brassicas, I don't know how they will behave during the mission, so being in a space actually. And basic and advanced workshops experience for educational purposes that we can be also prepared and just simply applied to Earth. If we talk about guidelines to be applied to daily routine, health and safety measurements, education, improved guidelines for mental care and psychological health, and we can say well-being. And we should also consider some catastrophes and accidents, not only inner, but also outer the greenhouse, outside the greenhouse, outside the base. So any guidelines which we can prepare and of course tried, they can be also applied to the daily life on Earth. And yes, sustainable development goals. This is something very important because obviously as a humans, we decided to achieve these goals, and we still have 8 years to achieve sustainable development goals. Maybe from the 17 areas for SDGs, I can propose that these are the most important, for instance, during this mission. So health and well-being, SDG 3, this part, training and education of astronauts, also sex balance, water saving, energy efficiency, waste recycling, any kind of management, also partnership to do in a cooperation. This is for me the most one of the most important goals to achieve. But looking at the American scientists, which they studied these SDGs in the context of the space-based projects, which can play a key role in the urgent global endeavor, we can say, to achieve these goals, sustainable developmental goals. We can see that this orange one, it means EO. This is Earth observation. So Earth observation, we know after reading this paper that it is considered as a gathering of any information about the planet Earth. So these techniques, which are combined with the meteorological, for instance, satellites, have the great exposure in every, we can say, goals. Without SDG 4, that's why it is on red here in my proposition. Without, for instance, SDG 5, without SDG 10, and also is small represented in the SDG 16. These are also other sections which were considered by the authors of this paper, looking at the sustainable developmental goals. Probably we do not have more time to explain, but if there is such an opportunity to do that in the future, I will also give some thoughts and conclusions about this story. And in a moment, we can go to the Menticom for voting. It will be in 1 minute. But of course, we know many things, but still we are flying blind. There is too much information, but of course, we can make some puzzles and do everything to conduct new technologies and also research during our mission. There is too much information, but of course we have to be focused on a part of them. And at the end, I would like just to show you my contact and also say that in part, I talked to Justin Appel. It's a scientific consultation. And I would like to thank you for the opportunity to giving me some, for giving me some opportunity to talk about this greenhouse and this mission, how is my point of view. And if you have mobile just by yourself, you can use it. I would like to invite you for some small measuring, use some application, and that will be this presentation. So please go to Menticom, and I would like to say a little bit in just a few seconds. And you can.
Okay, thank you so much, Thomas. Congratulations for your presentation. Okay. And I concluded.
Still, we have 1 minute.
Yeah.
Yeah. If you have mobile, Professor and you, Saha, please take it. Go to the Menticom. And when you are actually here, so here there is a code what you have to write being on this site website Menti.com. I will do the same story. So I have also mobile and go to the Menti.com.
What are the codes?
Yes, the code is just upper 9860 or 7250.
If possible, write in the chat. You are welcome.
Can you please write it down in the chat
Okay,
box?
do you see my slide?
No, we couldn't see.
Okay.
Just write it down in the chat box. That would be better. The code.
It is not visible for you.
No, your slides are not visible for us.
So the code,
Tomasz,
yeah.
I'd like to suggest to stop the recording, okay? And you can continue. And I'd
Maybe
like to say, before to conclude the recording, I'd like to say congratulations for your presentation. It was very well done, very complete. Also, if Sarah would like to say something before to conclude the recording, and you can continue the conversation after the recording too. Sarah.
Yeah, I have just one small query. Hello, am I audible?
Yes.
Yeah. I have just one small query. Like as Thomas suggested that he wants to grow like broccoli and other vegetables in Mars. So what do you think about the cactuses? So are they more suitable to grow on Mars in such Martian arid conditions? As I know, some of the cactuses like dragon fruits and all, they are edible also and can be cooked. So can this be a good option? What do you think?
Why I have proposed broccoli, yes, for food production during the Mars mission. Yeah? Yeah, plants belonging to brassicas and also to the other orders like lettuce, for instance. Maybe they can be a very quick and in a quick step we can obtain just biomass to eat. Considering that it can be, for instance, a kind of plant where the vegetative period is just shortened to the minimum. So, for instance, in a short time, we can say that we can produce a biomass. I don't know if really broccolis, or Brussels sprouts or lettuce can be a possible food for the astronauts. I have to check it and, of course, be sure that we can use a kind of plants. But I have worked these plants, and I would like to compare if we can just short the period of vegetative to achieve these plants for food production.
Yeah.
Okay, wonderful. Okay, I'm stopping the recording. Yes, Thomas. The code to achieve the Menti code also is possible as access later. It's possible sharing the WhatsApp group because I'm a little worried because I need to